Hi, everyone. Well, we are at our last topic, and our last topic is chapter 17, which is sound and waves. In our textbook, it's actually chapters 16 and 17, but I call it 17 because it's just easier on me. This is a big one. This is going to take us 2 weeks. And so we're going to spread the information around a little bit. This is simple harmonic motion. And simple harmonic motion is anything that oscillates and repeats. Well, there's a lot of things that do that. That is everything from a pendulum going back and forth to a car spring when you're kind of bouncing when you go over a pothole, to water waves, sound waves, earthquake waves, light waves, lots and lots of really cool stuff. The information we're going to talk about, the definitions we're going to go through, can be applied to everything from electricity to x-rays. It is a really broad and cool topic. So we're going to go to Canvas and look over the course. Our introduction to waves, we're going to have a study guide like we always do. And here's something that looks very, very different this chapter compared to the others. Notice there's like 1, 2, 3, 4 pieces of information here and a lab, and then some equations before you even get to the homework problems. And that's because sound and waves is such a huge topic in definitions and ideas. And so as you go through this, make sure you're taking down this information, make sure you're getting the definitions and the ideas. I designed this to go over like a 2-week span if you're taking it during a normal semester, or one flurry of a week if you're taking it during the summer. And make sure that you get all of this lovely information. We're going to have 2 labs, a pendulum lab, and then later we're going to have a speed of sound lab. So in this video, I want to spend a little time talking about that pendulum lab, but let's kind of go through the rest of the full overview of the chapter. So then there's going to be some wave equations and homework problems that you can work on after we talk about things like the Doppler effect. The Doppler effect is that change in frequency you hear when an object goes vroom and a car goes by you. Standing waves in pipes, that occurs lots in musical instruments. Decibels is a way of measuring the intensity or the strength of a wave. Bow waves. And then we're going to do our second lab, speed of sound. We're going to have a last concept quiz and a last problem set. And then that will be all she wrote. So let's go and look at this pendulum lab. The pendulum lab, you are going to set up a simple pendulum. And how I'm going to ask you to do that is take the metal rod out of your lab kit, and it has to be really, really stable. So I took about 1/3 of it and hung it over my desk, and put about 2/3 of it on the desk, wedged it down with a hunk of clay, and then piled some books on it. This has to be very, 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 very stable. And then you're going to get a length of string. The exact length of the string you'll measure, but the first piece of string you take, you don't have to be real fussy about exactly what it is. And you're going to tie a length of string to this, and on the bottom you're going to bend a paper clip into kind of a fish hook shape. You're going to vary 3 variables for this pendulum. You're going to vary the mass that you put down at the bottom, the angle that it swings through, and the length of the pendulum itself. So we're going to have 3 different variables, and in each part of the lab, we're going to vary one of them. And the quest is, which one of these actually affects the period of the pendulum? Now the period, let's define period. Period is the time it takes for the pendulum to make one complete to and fro motion. So that means it starts here, goes and back again. That is 1 period. Period is not just all the way over. Period is all the way over and back again. And that is a measurement of time, and we're going to measure that in seconds. So in the first part of the lab, you are going to vary the mass. You're going to start with 1 washer on the bottom, then add a second and a third, and you're going to continue until you have 6 washers. Each time you add a washer, you mass that individual washer, then add its mass to the mass of all the washers before it to get the total mass added to the bottom. Human reaction time, as we all know, can really mess up our measurements. So what you're going to do when you measure the period of the pendulum is you are going to measure it for 10 complete to's and fro's. So you are going to pull it back a measured angle. For the first part of the lab, I suggest you just pick an angle and do the entire part using the same angle. And you're going to pull this pendulum back for all the way back, and you're going to measure it for 10 complete to and fro's. So 1, 2, 3, 4, and then you're going to do that. And when you've gone 10, you're going to hit the stopwatch and go stop. Now, the trick to doing that well is when you start the stopwatch, say 0, 1, 2, 3, 10, stop. And then when you take that time for 10 swings, divide by 10, you will have an accurate time for 1 swing. Most common error in doing this lab is not counting correctly. So take time to make sure you understand how to count to 10. So the first part of the lab, you're going to change the mass hanging on the end of the pendulum. The second part of the lab, you are going to change that angle. So if you swing it from a little angle or swing it from a big angle, what effect does that have? So I'm going to ask you to start with a small angle, 5 degrees from vertical, really small angle at 5 degrees from vertical, time for 10 oscillations, and then find the time for 1 swing. And then in the third part of the lab, you're going to change the length of the pendulum. How are you going to change the length of the pendulum? Well, you're going to keep the angle and the mass on the bottom the same for this part of the trial. So we're changing 1 variable per trial. And the easiest way to change the length of the pendulum is every time you want to change the length, just take this string and go and loop it around the metal rod. You can loop it around once, you could loop it around twice. You're going to get 8 different length measurements and then time it for 10 to and fro's. And you don't have to take data in order. So if you find that you only have 6 data points and you go, oh, what am I going to do to get some different ones? Well, then unloop it. It's not real complicated because you're not cutting and retying string. It's a really easy way to change the length of this pendulum quickly. When you are done with this, I'm going to ask you to do some graphing on Excel. And if you're don't remember how to make a physics graph on Excel, please refer back to the video I made on how to make that physics graph on Excel. When you do that, the acceleration of gravity, you're going to do a little manipulation of the slope. The slope is going to be equal to 4 pi squared divided by g, and g is going to be our acceleration of gravity. You're going to do a little algebra, solve for g, and then throw your slope and 4 pi squared in there, and you should get the acceleration of gravity out. This lab works really, really well. It's one of the best and most accurate ways to find the acceleration of gravity. So best of luck with it, and we'll come back in another video and talk about the other lab. See you soon. Bye-bye.